Okay, I think that we can now begin. I hope that almost everybody are here. So welcome to you all at RockCheck webinar, which is a part of 6th European RAM at School conference. My name is Nina. And I'm a geologist, and I'm working at Geological Survey of Slovenia. So as you can imagine, I really love rocks, and I say that rocks. So because of that, we named this webinar like we did, RockCheck, you rock the rocks. So today, just a moment that I admit all the people inside. So today we will, in the next 30 minutes, we will go through what is a RockCheck, which is an application for identifying and classifying rocks, which can also help you to learn more about typical rocks and geology in general. Before that, we will do a short introduction about basics of rocks and minerals. But for now, let us start with the question, why we actually need to learn about the rocks? Why is this important? So rocks are almost all around us, and they have a big impact on our life. For starters, they built up the earth crust, and so they are a foundation for example, soil on which plants can grow, and rocks are also foundation for our building and infrastructure, and rocks also build terrain around us, so we can have mountains and valleys and so on. Rocks are also reservoirs for the drinking water that we pump from them, and they are also reservoirs for oil, for example, that we use for energy, electricity, and so on. And from the rocks, we also mine raw materials from rocks that we call ore. And from these raw materials, we make all these different items that we use every day. For example, this one here, these ones here. And from these raw materials and rocks, we also build our buildings or infrastructure, and also all the green technology, for example, wind turbines and solar panels and so on. So I think that we can agree that rocks are very important, and it would be good if everyone should know something about them, about rocks and minerals. But why I am mentioning minerals as well, if we have rock application? Because minerals are very connected to the rocks, because they are basic building blocks of rocks. So every mineral has it, by the definition, mineral is naturally occurring homogeneous solid, which has constant chemical composition and ordered crystal structure. And because of that, every mineral has its own properties, on the basis of which we can identify them. So if you look at this picture, we see that minerals are different colors, they have different luster, they have different transparency, shape, and so on. And for some of them, we can also do some experiments to determine which mineral we see. For example, we can check the hardness of the mineral with a glass plate. We can check the which color is the streak of the mineral on ceramic tile. We can try do the test with acid and see if mineral reacts with acid or no. And also some minerals are, for example, magnetic, so we can try them with the magnet and see if they are or not. There are a lot of different minerals, more than 4,000 different minerals, but only a few of them are those that actually build up rocks. And if we know the properties of these minerals, this can help us to identify rocks as well. So, for example, if I have this rock here, this rock is made only from one mineral. And here I have 3 different minerals. And as you can see on the first glance, you cannot say which mineral built up this rock, because they are all the same color and so on. So we can, for example, do the test with the acid. Today we are online, so you need to believe me. But if we will be somewhere in person, we would do this experiment. But now, unfortunately, we can't. So if we will drop an acid on the rock, it will react with the acid. So we can conclude then that we need a mineral that also reacts with acid. And if we will try this, only this mineral here will also react. So we can say that probably this rock is made from this mineral. And on the same basis, we can do the test with the all rocks and try to build them with minerals. Also, for example, this rock here that you can see on the first glance, that it's made from more than one mineral. And it's true, it's made from these 5 different minerals, which we can determine with different experiments and observation. So, as we already said, rocks are made from the minerals. And because of that, we say that rocks are solid substance with more or less constant mineral and chemical composition. So rocks, as we also said in the beginning, builds up earth crust, lithosphere, and we have different types of rocks, of course. And we can classify these different types of rocks into 3 main groups, according to the processes by which they were formed. And now we will look at these processes and how this changes in the graphic presentation of rock cycle. So this rock cycles is an overview of how rocks can change from one type to another type, and also how they are formed below and on the Earth's surface. So we will start with the magma. And if this magma starts to go to the surface of the Earth, in the one point there, this magma will start to cool down and crystallize. So minerals will start to grow. And this usually happens on the areas where we have volcanoes. So for example, in this picture, when magma starts to go up, it starts to cool. And so we get igneous rocks. But you will probably ask me why there are so many different igneous rocks if they are all formed in the same way. This is because this depends on the magma. Magma is a substance that is in which we can find different elements. For example, oxygen, silicon, iron, and magnesium. And so, so which rocks will be formed depends on the composition of this magma from which rock is formed. Also, it's different if the rocks crystallize on the surface of the Earth or below the surface of the Earth. This we see in the different structure of the rocks. For example, if it's crystallized below the surface, we have structure like this, here somewhere. And if it's cooled on the surface, we have different structure. These igneous rocks can then be remelted again and again be magma. Or they can be subjected to the different processes on the Earth's surface, for example, weathering of the rocks, and this results in the creation of sedimentary grains. These are grains that vary in size. They can be very small that we can no longer see with the naked eye, or they can be as big as, for example, pebbles. And these sedimentary grains are a lot of times transported by different medias on the Earth, like, for example, water and wind, to the different environments on the Earth. For example, lakes, rivers, then coasts and oceans, for example. And you can see these sedimentary grains, for example, on the beach when you walk on the sand or gravel and so on. And when these sedimentary grains are deposited somewhere on the Earth, we say that they sedimentated there. And if there are right conditions, these sedimentary grains sticks together with different processes, and we said that they lithify together, so stick together, and so sedimentary rocks are formed by this. If sedimentary rocks are formed from sedimentary grains, we say that they are clastic sedimentary rocks, but we also can get chemical sedimentary rocks, which are formed by precipitation of minerals from aqueous solutions. A lot of times also dead organisms are deposited with sedimentary grains, and these dead organisms are then we can see in the rocks like fossils. If all of these rocks that we mentioned before now are then by different processes somehow how can I say this? If by different processes, like for example, earthquakes, faults, and tectonic plates, these rocks can go deeper below the surface of the Earth, but not so deep that they can melt, but they are not on the surface. And there they are subjected to the high temperatures and pressure. And so they changes in the, they change structure and chemical composition. And we say that they metamorphize. And so we can get metamorphic rocks. These rocks are changes so because of different pressures and different high temperatures. And for example, if they are on the if there is only pressure that works on them, then we can get a structure that has layers, because pressure do this to the rock, or we can only have, like, for example, here, change in chemical composition, and we have no layers. So this was a quick representation of rock cycle and how rocks are formed and how they changes from one type into the another. So for oh yeah, I forgot that also metamorphic rocks, if they go deeper inside the earth, they melt. And of course, if they are by processes subjected to the surface, they can weather, of course, and we can we again get sedimentary grades. So this was quick presentation, and so that we go quickly through the classification of rocks. So we have sedimentary rocks that can be clastic, so made from sedimentary grains, and chemical, made from minerals, from precipitation of minerals from water. We have igneous rocks that can be intrusive, so they cool below the Earth's surface, and extrusive, which cool on the Earth's surface. And we have metamorphic rocks that has this schistosol structure, we said, that they have layers, and granulose structure that they only change their chemical composition. And now we will try to use RockCheck application, as I mentioned before, which is for identifying and classifying rocks to identify these rocks that we already see. I will just try to share my screen in different ways so we can, just a moment. So we can also see the RockCheck application that I have here. Okay, maybe like this. So for here is a RockCheck application. I hope that you all see it. It's made from RockKey, Encyclopedia, and School of Rock. Encyclopedia is the part of the application where you can find different rocks by name or by picture, and then learn more about them. For example, you can see the description of these rocks, from which minerals it's made, and so on, formation, how it was formed, and also some interesting things about a specific rock. Then in the School of Rock part, you can learn more about basic stuff about minerals, rocks, and so on, in similar way that we also see before. And also you can look at the short videos. For example, this one, how you can do a short experiments on the rocks in the application. And now we will use RockKey to determine the rock that we see in here. This part only said that we need to look at the rocks in a freshly broken surface, and that we need to observe it very closely and answer on the questions. Of course, I have here a picture, but ideally it would be that you will look at the rocks in front of you, of course. So the first question in the application is if you see mineral grains in the rock. We need to look at this picture, because this is only a picture for helping us, like that we see how mineral grains looks in the rock. and you need to see this picture. And also you can go through this link to the School of Rock, where there is written more about mineral grains, how they look, and so on. So now we can answer that these rocks is made from mineral grains, because we see different small minerals, different colors inside the rock. So we said yes. Next question is the rock have layers? So layers are something like I showed before that we have in metamorphic rocks. It also can look like this or something similar. But as you can see, this rock does not have layers. So we said it doesn't. Next question is if the rock composed of mineral grains that are in contact with each other. We can also again look this in the School of Rock, how this looks. This only means then that mineral grains need to be packed together and they need to contact with each other. And as you can see on these rocks, yes, mineral grains are in contact with each other. Are all mineral grains in the rock white? No, this is a very simply question, and we can say no, they are not all white. Are they green, red, or even blue color? We cannot see green or red mineral grains, so no. Are mineral grains in the rock approximately the same size? This is really meant like if they are approximately the same size, or that there are a lot bigger sedimentary grains and some smaller. And for these rocks, we can say that they are all approximately the same size. Are mineral grains in the rock mostly dark or mostly bright? So for this rock, we could say that they are mostly bright. So no, they are not mostly dark. Are mineral grains in the rocks pink or red? Maybe this picture is a little bit not so good for this, but if you will look very closely, you will see that some of these mineral grains are like a little bit pinkish. So yes. And do you see transparent or translucent mineral grains? This again cannot be seen very well on the picture, but yes, there are transparent mineral grains in this rock. So yes, and we get our answer that this rock is granite. And now we can read more about it in the encyclopedia part that I showed before. So description, information, and interesting facts about this rock. Okay, I see that we have maybe a few more minutes. So I will ask you that maybe think about if you have any questions and write them in the chat. But in this time, we will try to do another rock. We will try to determine another rocks with the application. We just delay this one, and it will be this. So again, we go to rock key. If it have mineral grains, this is a very tricky question because these rock don't have mineral grains. It has sedimentary grains. These are sedimentary grains, but sometimes this is difficult to see. So you need to look very closely how they are looked to you. So these rocks, no, it has not mineral grains. If it has sedimentary grains, yes, we say that has. Do you see fossils or fossils predominating the rock? No, we don't see any fossils. Are sedimentary grains predominantly larger than 2 millimeters? Yes, some of them are very big, almost 2 centimeters. Are sedimentary grains rounded? No, they are not rounded. They have pretty irregular shape. So no, and we get our answer that this rock is breccia, which is of course sedimentary rock, and also we can learn more about it in the application. So I will stop share my screen now. I see that there is no question in the chat. If somebody has anything to ask, please do it. Otherwise, I will thank you everybody for attention and invite you to download the RockCheck application on your phone. It's freely available in Google Play Store, and it works on Android devices. So please download it, try it, and try to determine rocks that you find around your home with it. So, okay, this is all. Thank you and have a nice day.